Welcome back. My name is Saptak Sen. I'm a Senior Product Manager in the Microsoft Azure Data Platform team, and I have with me Bill Ramos.
Thank you, Saptak. I'm Bill Ramos. I'm VP of Consulting Services at Advaya, and I'm going to be doing a bunch of demos for this session today.
So, talking about today's session, this session is all about how do you develop big data applications with .NET. So, in the past sessions, we discussed about Hive. Now, Hive is SQL-like enough that if you know SQL, you can really get productive fast for big data applications. But we are going to go even further. If you are a .NET developer and if you use something like LINQ, LINQ, or language integrated query, how do you get to do your big data applications? And then we are going to do something a little different from what we have been talking about in the last few sessions. We are going to talk about reactive extensions. And with reactive extensions, you'll be able to deal with streaming data. And how you can use that, we'll look at that. So let's get started. Let me first start with describing a little bit about LINQ to Hive. Now, if you are familiar with LINQ or language integrated query, language integrated query, as the name suggests, provides you a very simple way to embed a query in .NET in a data workflow language. Now, it's a lot of .NET developers really love the syntax. They don't have to pass SQL queries in clear strings, which is not typed and so on. So that's why it's very popular. Now, what LINQ to Hive provides you is that now you can use the same construct, same syntax to basically trigger off Hive queries on Hadoop clusters. And in this case, the Hadoop cluster we are talking about is the HD Insight service. Now, what we have done is with a library, we have built a translation layer where your LINQ queries get translated into corresponding Hive queries. And then the Hive queries themselves, by the Hive query engine, gets translated back into MapReduce jobs, which then run on the distributed infrastructure, that is HD Insight service or Hadoop. So this makes the developers, .NET developers, a lot more productive because they are not having to learn any new technology to take advantage of a distributed infrastructure like Hadoop. Now, enough said. Let's move to the demo.
Yeah, thanks, Saptak. So what I'm going to be doing today is going through and showing you a basic LINQ to Hive query example with Visual Studio. So the first thing I'm going to do is go ahead. I've already launched Visual Studio here as my environment. And I'm going to go ahead and create a console application and call it, no thank you, LINQ to Hive. And of course that warning was my caps lock was on. Okay, so as part of this example, I already have some code set up that I'll use for the application. And what I'll do is I'll go ahead and clear this code out and go ahead and bring in my application code that I have over here, and then I'll walk through it, the different components of it. Now you may be wondering about all these scripts that we're doing for these demos. We're going to make these all available somehow either through GitHub or through the Download Center so that everything's available for you as well so you can try it out yourself. Yeah. Okay, so we have our program. You'll see we need our Hadoop reference. So we're going to go ahead and, like we did before, go to Tools and our Library Package Manager and launch the Package Manager console. From here, I'm going to go ahead and then bring in our two modules that we care about. One is our Microsoft Hadoop Hive. And so this is going out, resolving through NuGet, bringing in the dependencies. And we're going to bring in, we'll take a chance, and I don't think I need to bring in the other one. Okay, so let's walk through this program example. It's just a basic program where we have our main routine. What we're going to do is set up a series of variables to set up the account. When we actually download them, you won't see all this account information, and so all these passwords and things like that aren't going to be useful for you after that. So the first thing we'll do is we'll indicate what our account name is for our storage account, because what's going to happen is that the application needs to know where the results are going to be as part of this application. We set up our cluster name and our username and password for the cluster. We also provide a cluster URI, which is the reference to the cluster so that we can get data in and out through port 563. I'll go ahead and display a message as we're going through here and setting up a Hive connection. Now what I'm going to do is I'm going to go ahead and set a breakpoint here, just so that when we demo the code we can just walk through it line by line. So the Hive connection actually sets up a connection to the Hive database through this helper class that will allow us to go ahead and connect to the system. Once we're connected, we're then ready to do the LINQ query. Now in this URL that I've provided in this code, there are a variety of samples that show how to build LINQ queries using Hive. And more importantly, there's a lot of great examples of how to do joins and group bys and order bys and things like that I'm not going to show in this example, but I do want to show you the essence of a query. Similar to what you do in a LINQ query, again, you display where you're getting your data from and indicating the essentially the name of the table object, which is a class, a helper class that's set up down below here. So let me go scroll down at the bottom here. And so as part of the Hive connection, we indicate where to get the table information from. And so we have here our method that's part of this helper class. We indicate the name of the table that's actually the Hive table on our HDN site cluster. And then the get table will send the correct metadata back to the class. The other thing we have to do as part of the definition in the helper class is we have to build out how to get the state, county, age group, and total information. And so it's just a simple operation based on your table structure. You'll build out these two helper classes to identify your table. This isn't really automatic yet, but it's pretty straightforward code to copy and paste once you get the hang of it. Okay, so if we go back to our code here, I hope we were looking at the code or we're doing that.
Yes, yeah.
Okay, good. What we're doing here is we're then saying, setting up a where clause. So I wanted to show an example of a where clause in the example where you can go ahead and the main difference here, especially if you're a T-SQL programmer, is that you're using equal signs as logical variables that are consistent with the language, in this case C#. And so we're using equals equals, or you use not equals. So that threw me for a loop the first time I tried to do this application. I put in a single equal there, and I got this error, and I'm going, well, what the heck? And so I had to go back to the sample thing here and throw in my equal. Remember, I'm a Transact SQL guy by trade, learning .NET. And so that was the whole point of what the cap theory, right? It has to be simple. It's one of your imperatives, right? Okay, and then finally we say we'll select census, and then by default what this will do is select all the columns from the census table, basically using the information that we have down here in our class to define the columns as part of that definition. It'll go ahead and run the query, and then to do that, as part of the framework, we use the execute query method that will go ahead and fire off the query. Now one thing that's important here is we have this wait clause. What this wait clause will do is it will go ahead and stop processing, or it will allow the Hive query to complete before we get back to the results. Otherwise, what will happen is the application will just start running and continue to run on, and when we do this getList command, which will actually build the list of values for the query, you end up with an empty set. And so with the .NET framework, as far as with Hadoop, this method has a wait method on it that will go ahead and wait for query execution. Finally, we'll go ahead and display the total records found, and that's it. So let's give this thing a whirl. So I'll go ahead and build a solution just to make sure I didn't forget anything. Build succeeded, and we'll go ahead and start. Okay, so we had a console window pop up here where we'll keep track of our results. You'll see here that with our, we're getting ready to execute what's going on, and then again, because I'm going to go and start doing the step into. So we'll go ahead and set up our connection, and again, here's what it's going through our class definition to set up our table information, and now we have a Hive connection that's set up for the operation. We're then going to go ahead and run or set up our LINQ query. Now this is actually running at this point, so we'll go ahead and define the variable. And now we'll go ahead and run. Okay, at this point, we threw an exception. And what it's telling us is could not load an assembly. It's because we're missing an assembly, right? And so one of the things that's happening, and I'm glad I did this, is that we need one more library set up. So even though in the namespace declaration we didn't have a reference to one of our other packages, I do need to create that reference. So I'll go back to Tools, Package Manager.
Do you stop the running of the thing?
Oh yeah, I can do that. Thanks. You've done this before, haven't you? Okay, so we'll go to Tools, Package Manager, Console, and now we'll bring in the other one. So what we need to do is bring in this Hadoop Web Client, which is another component of the .NET framework. And that will allow us that has the query execution capabilities built into it. The rest of the stuff is basically to support MapReduce. And so we're using this Web API client to do the information on it. So go ahead and let this run through. Now we have what is probably everything we need to do the command. So what I'm going to do is close this window, and I'm going to change our breakpoint now to right here. And go ahead, build, and we'll start. Okay, so we're now at the wait command, and we'll go ahead and debug. I guess I can step over. Aha! Now we're in good shape. So what's happening is we're going ahead and executing the Hive query to get results. So this is actually doing the MapReduce job, or translating the LINQ query into HiveQL, and then that HiveQL is generating the MapReduce programs to go out and do the query where we're doing the condition of where the information equals California. And so this will take a little bit, hopefully about 30 seconds or so.
Yeah. By the way, if you are not familiar with Hive queries, look at some of our earlier modules, specifically the module just before this one, where we cover Hive queries in quite a bit of detail. So that way you know what we are talking about. Maybe we can go to the job manager and see if the query is running.
You want to try to go into the job manager? So the reason we're chuckling is up until about 30 minutes ago, we weren't sure whether this was working. So the job manager, again, is under Manage Cluster.
Okay.
And so we'll see if this works. If not, we'll probably have to bypass this step.
Sure.
But let's go ahead and cross our fingers now.
Yeah.
And hopefully we will see something here.
By the way, has it completed? Your
yeah,
little
we actually
console
completed. let's see, yeah. So the console application, if we go back here, we now have our results set back. So we'll go ahead and let this thing run. We'll go ahead and we'll do our F10. Now the next thing that's happening is we're going to go through and let's look at our console. We can see the number of records that we found in the output list. And then we'll go ahead and continue here, wait for our key. And we're now, that's it. You know, we got the count of records where the number of items equaled California.
So in short, what you just saw is that we have a Hive table on our Hadoop cluster, which is running on Azure. That Hive table is basically a schema on the raw data file sitting on the Azure Blob Store. Now, Azure Blob Store is a distributed storage. You can store a lot of data there, and then you have this Hive framework to run MapReduce jobs pretty simply. Now, you wanted to do it from your client application. So from your client application, using LINQ to Hive, you can now write the .NET code in your client application to go run that query and get the results back without having to learn much about Hive and Hadoop. So that's I think a huge advantage and benefit that we provide over any other framework that you can use to do Hadoop programming. Because you essentially, if you are a .NET programmer and you know LINQ, you don't have to learn anything new. So with that.
Yeah, so let me just go back real quick.
Sure.
If we go back to our, my screen here, I'll show you. Within our dashboard, we can see that we had a MapReduce task run, and so that was the MapReduce job to do the select statement that was taking place. And again, normally what you would do as part of your query and your execute after the to list is you might bind this to a table or something like that where you'd show the results in your application.
In a grid or whatever,
yeah.
control.
Yeah, in a grid control or whatever. So that's it for LINQ to Hive. Again, very simple constructs. What you're going to do, again, is you do have to build these helper classes for your Hive connection and for your data records. These are well defined in the SDK, and there are plenty of great examples here on the Hadoop SDK and Coplex on their wiki page for showing you those examples. So that's it. So let's turn it back to Sapdak now.
Awesome.
To go on to the next part.
So now I'm going to talk about something else other than Hadoop. Now, one of the scenarios that we have often seen specifically around big data is the ability to process streaming data. And this is especially important because as we saw in the speed layer, whatever comes to Hadoop, you can process it as a batch and then update your analytics data staging place, and in this case it can be analysis services. We have a second training coming up which is called analytics with big data or big data analytics, and look out for that, and we'll cover more about that in that training. But the ability to process streaming data is crucial in big data. So for that, we have something called reactive extensions. Now, reactive extensions essentially lets you subscribe to data streams, and as certain events fulfill, you basically have this observable interface from your code, then that gets invoked by the framework. And this is as opposed to what you do if you wanted to just pull or poll data. And pulling or polling data works well for most purposes, but it's expensive because you are basically in a loop or whatever, and you are checking every now and then if the right event of your interest is has happened or not. Whereas in case of a reactive extensions framework, you can basically subscribe to it using the iObservable interface. Now let's look at the demo of reactive extensions, how it works.
Okay. Thank you, Saptak. So I really don't have any streaming data here, but what I'm going to do is use an example that we built out with crime data based on population that's available actually on Windows Azure Marketplace. And we'll actually go through the details of setting that up in a future module. But if we go back to the screen, I'll show you kind of the data that we're going to use to simulate the streaming activity. So the file that we're using here is a CSV file, which has a state, a city, the population for that city, and the number of crimes that took place during that city. These could be property crimes, auto theft, larceny, those kinds of things. And we also have a percentage value that represents kind of the population or the crime divided by the population to indicate, kind of what's going on. And so in Alaska and Anchorage here, it looks like there's an 8.5% crime rate based on the number of people in here. And so what we're going to do is we're going to set up a streaming job that will look at this data and look at a percentage that exceeds a certain value. And if it does, we're going to go ahead and write those values out as we're processing the data. So essentially we'll have a routine that reads through this data, and then as part of the reactive extensions, when we find that data, we'll go ahead and write it off. So in a way it's through the stream processing. Okay, so that's the crime file that we're going to work with. And I'm going to make sure that we've got that right. And what we're going to do now is set up our project. So let me go ahead and File, New Project, and we'll call this RX Crime. And we'll take this code out and place in the next code. And I'll walk through this here once I get it loaded in. And we'll paste that in. Now, up in the until the past, I've been using the package manager, going through the library package manager and using the package management console to get our libraries. But I'm going to take a slightly different approach here, where you can actually search for particular packages that you want to install. And so what I'm going to do is launch the Manage NuGet Packages for Solution. And from here, I can go ahead and search online for for packages. Oops. Let's go ahead and go back here. And if I type in reactive extensions, it'll go ahead and search, and I see all the library modules that match reactive extensions. Now I've got to bring up my little cheat sheet here to make sure I get the right ones. And so I'm going to bring in the main library. And accept that. Now when I bring in the main library, it pretty much brings in all the dependent items that are associated with that package. And then I'm going to bring in the WPF helpers. No, I don't think I'm using it. I just want to make sure I don't run in the same situation I did before. And then I'm going to bring in the XAML support libraries already set up and the testing library. Okay, now I've set up my libraries and all the references are set and my reactive LINQ extensions here are set up. Now, the reason we showed LINQ to Hive earlier was because reactive extensions is based on LINQ. Okay, so now we have our references set up for the application. As part of the program, we have our program class, which defines our crime class, which has the, again, remember back to the CSV file right here. We have our state, city, population, total criminal activity, and the percentage. In our main routine, this is where we set up our observable class based on crime. And what this does is we'll go ahead. Actually, let me go ahead and continue to walk through this thing here. What this is doing is actually setting up our pull process, right?
Yeah, the observable interface.
The observability interface. Yeah, yikes. Okay, and so what we're doing here is we're basically saying as the data is flowing in with our event pattern, it'll go ahead and basically add an item to the collection based on what's going in. And if something changed, if all of a sudden we got a value that was outside of our criteria, it would take it out of the interface. And so based on the data streaming in, it will go ahead and determine how to add and subtract items. Here's where we set up our LINQ query where we're going to watch for crimes. Actually, we're going to look for really high crime places and change this to 100%. And so what we're doing here is we're saying there's actually a two-part query here that's going to be set up. So for the most watched crimes, and this is basically looking at just the crime data that's coming in, and so this is going to collect all our end results. We're going to look for an action where the collection was notified that the action changed and go ahead and add the item based on our query below. And what this query below is basically doing is saying from our new items that are coming in from the crime CSV file, whenever a crime percentage exceeds 100, we're going to go ahead and set up the action to actually look at the data, what's going on. We'll specify our input file here, which is our city crime CSV file. We'll also create the output file, and this is an output file which will append the data to based on what's going on. And so in a streaming activity, you tend to keep your output file open so that the data coming in is streaming through and getting results. Then for each item that we got out of our crime changes, we're going to go ahead and display the city, state, population, and crime percentage. Now what happens here is this is the handler for setting up the condition. So what we're going to do is set up essentially our stream for the most crimes, where we'll go ahead and bring in our crime data, or this is where we write the data out. So we'd write out our data as crime data with the values based on the condition that was set, and we'll use the system file I/O to append the data to the system. Okay, so that's set up the event handler. We set up the data, set up the event handler, and now we're going to go ahead and start doing the processing. The way the processing will work is we'll go ahead and make sure the file is there. Then for each value in the all crimes, we're going to go ahead and split out the data in a comma-separated list, and we'll create our crime object. So in memory, we'll go ahead and create our crime object, which is based on the data values here, where we load in the percentage. And then we go ahead and do the add. So what's happening is the file's being read in. It's then, because we set up the event handler, when we do the add, it's then going through and checking the event handler to see if the condition's been met. And if the condition's been met, it will go ahead and write to our output file, all at the point where we do this add. And then finally, we've got some error tracking here to make sure that the input and output files are all created and everything works. So let's give this one a whirl. So we'll go ahead and build it. And I'm just going to let it rip. So just like that, so if we go back, if we look at the screen here, the output result here, we can see that all these values are greater than 100. It looks like the city of industry is not a place to visit, or the city of Vernon, given the crime rates there. But you can see the data was actually pulled based on the LINQ query again, when the add method took place as the file was getting read in, took the output, wrote it to the file, and that's it. So a very simple program to set up a streaming activity against our data to go ahead and essentially process streaming data using LINQ queries.
Awesome. So what we just saw is that you can now use full fidelity, LINQ queries or LINQ constructs within .NET to process files on Hadoop and in a batch mode and gain that insight. So when you are trying to basically basically crunch through a lot of files which are sitting on the Hadoop cluster. Now, the other side of the coin is when you have changing data, you have streaming data coming in, and you want to apply those rules based on a LINQ construct. You don't have to learn anything new. You can use the same .NET languages and the LINQ framework to now apply those rules on streaming data, and when it meets some of those rules set by LINQ, then you get the event through the iObservable interface for you to react or to do anything that you want to do with it. So
I forgot one little step. If we can go back to my screen here, I just wanted to show the output result file here. For our Rx crime result, because we saw the data being displayed one way in the program app, but the end result was you have to have something to process, right, with something like Excel. And so here again, what we've been able to do is I just opened up the Rx crime file. Every time we run that, it will go ahead and append the results, and we see the data here. Now, this is something that we can actually react to with tools like Excel and stuff like that.
Right.
Awesome. Okay, so that's it for reactive extensions.
If you want to learn more about it, we have some links here on the screen, and there's a lot of documentation on it. So please visit this, and in the next module, we are going to look at how we can operationalize Hadoop by using PowerShell scripts and other methods that you have by using the SDKs. So with that, we'll come back on the next module.
Yep.